Hey everybody, and welcome to this video on rationalizing the denominator. So let's get the show on the road. Alright, consider the fraction 6 over the square root of 3. Now in general, we tend to prefer nice integers to fractions. But hey, what can you do? Sometimes you gotta deal with a fraction, and there's no two ways about it. However, not all fractions are created equal. This fraction makes me a bit uneasy because the denominator is so unfriendly. If you wanted to do anything with this fraction, maybe add or subtract it, or even multiply or divide it, it would be a lot easier if that denominator were a lot more user-friendly. And why is this denominator such a difficult number to work with? Well, we're taking the square root of something that isn't a perfect square. And whenever you do that, well, we can't simplify this much. If we wrote it as a decimal, it'd go on and on and on forever and ever, and it would never repeat. So definitely not very user-friendly. If we were taking the square root of a perfect square, like 4, 9, 16, 25, 36, etc., well, that'd be really nice because the square root of a perfect square will just give you an integer. So our task here is to somehow come up with an equivalent fraction to this one, such that the denominator is no longer the square root of something that isn't a perfect square. So if we change this fraction so that the denominator were the square root of a perfect square, we would get a nice integer in the denominator. We'd be good to go. So the question is there anything we can do to the square root of 3 that will make it into the square root of something that's a perfect square? Well, we know that we can multiply one square root by another square root. And my question is, can we multiply 3 by something in order to get a perfect square? Well, the easiest thing that comes to mind is 3 itself. Of course, the square root of 3 times the square root of 3 will give the square root of 9. And the square root of 9 is a nice number. That's just 3. Now, of course, since we need to come up with an equivalent fraction, we need to make sure to multiply the numerator and denominator by the exact same thing. So we'll multiply this original fraction by the square root of 3 over the square root of 3. And that gives us 6 root 3 over 3. Another way to think about it is, by definition, the square root of 3 times the square root of 3 is 3. So if you'd like, you may certainly skip this middle step right here and go right from here to here. So we've successfully rationalized the denominator. That is, we now have an equivalent fraction whose denominator is now a nice number, 3, instead of that unfriendly irrational number, the square root of 3. However, there is still some simplifying to do here. I see that we've got a 6 in our numerator and a 3 in our denominator, and I know that 6 over 3 simplifies to 2 over 1, or simply 2. So we end up with 2 times the square root of 3. So in this case, it happened to be that making our denominator into a nice rational number, in this case 3, ended up allowing us to do some more simplification. It won't always be the case, but hey, that was pretty sweet. Let's try another. How about 7 over the square root of 5? Alright, we'd much prefer to have a much more user-friendly denominator to this fraction. So we're going to need to multiply the numerator and denominator by the same number so that we somehow have a nice number in our denominator. Well, if we multiply the square root of 5 by the square root of 5, our denominator will become the square root of 25, which is 5. Of course, since we need to make this an equivalent fraction, we multiply the numerator and denominator by the square root of 5. And we end up with 7 root 5 over 5. Again, if you'd like, you can skip this step right here because we know that by definition, the square root of 5 times the square root of 5 is 5. And in this case, there wasn't anything we could do with that fraction at the end. No more simplification. That's as good as it's going to get right there. And in general, it appears that if we ever have a fraction with a square root in the denominator, we can always get away with multiplying the numerator and denominator by that square root again. And then we'll end up with that original radicand as our denominator. Alright, so here are 2 examples for us to practice. Why don't you pause the video and please rationalize the denominators for these 2 fractions, and then when you're done, play the video and we'll see how it went. Awesome. See, it's not so bad. But let's take a look at a few more examples where this strategy might not actually be the most efficient. For example, 3 over the square root of 8. Now, we certainly may multiply this fraction by the square root of 8 over the square root of 8, and we'll definitely get a nice integer for our denominator. However, in our resulting fraction, I see that we've got the square root of 8 in our numerator. And that, I think, we can simplify. So we're not actually done now. We've got to simplify the square root of 8, and maybe we'll have some canceling and simplifying to do in this fraction. Wow, that ended up taking a whole lot of steps because we ended up with a fraction where we could simplify that radical. So let's take another look at the same problem. Remember, what we're trying to do here is somehow change this square root of 8 into something where we're taking the square root of a perfect square. In our first example, we ended up changing it into the square root of 64. But is there another multiple of 8 that's smaller than 64 but still a perfect square? Yes, 16. So is there a way that we can somehow change the square root of 8 into the square root of 16? Absolutely. All we need to do is multiply this original fraction by the square root of 2 over the square root of 2. And look how much more quickly we got to that answer. So, while just multiplying by the square root will always work, we need to keep in mind that we may need to simplify later, and there may be a more efficient way to take care of the problem. Alright, now what happens if we have a third root in our denominator, such as with 3 over the third root of 4? Now, a lot of folks immediately have the inclination to just multiply the numerator and denominator by the third root of 4. And there's nothing wrong with doing that, but 16 is not a perfect cube. So we don't end up with a nice denominator like we hoped, right? A third root times a third root multiplied by themselves twice doesn't give you that number. So in this case, what we actually had to do is if we wanted to use the third root of 4, we had to multiply the original fraction, its numerator and denominator, by the third root of 4 twice. And remember, by definition, with a cube root, you have to multiply it by itself 3 times in order to get 4 in this case. And we end up with 3 times the third root of 16 over 4. Now note, there's another way we can think about what we just did. Of course, when we look at this original fraction, our goal is to change that denominator into the third root of something that's a perfect cube. And we know that 64 is a perfect cube, and that's a multiple of 4. And so what we've actually done is we've multiplied the third root of 4 by the third root of 16, which gave us the third root of 64, which of course is 4. All right, now we may think we're done, but wait a second. The third root of 16, we can simplify that. Yowza, that was a lot of work. And because we ended up with a fraction here, where there was still some simplifying we could do, it makes me think that there may have been a more efficient way of taking care of this problem. Remember, when we look at our original fraction, all we need to do is change this third root of 4 into something where we're taking the third root of a perfect cube. Now the question is, are there any multiples of 4 smaller than 64 that happen to be perfect cubes? Wait, there is. 8. So is there anything we can multiply 3 over the third root of 4 by in order to get the third root of 8 in our denominator? Absolutely. The third root of 2 over the third root of 2. Wow, that was a lot easier. So, remember, all we're trying to do is manufacture a denominator here where we're taking the third root of a perfect cube. You can certainly multiply the third root by the third root by the third root, but that'll probably lead to a situation where we have to do a lot more simplifying at the end. This was a much more efficient way. Just find the smallest multiple of that radicand, in this case 4, that happens to be a perfect cube. Let's look at another example right now where this strategy is going to be far more efficient and far more preferable. Alright, here we've got 4 over the third root of 32. And so what we need to do is somehow find an equivalent fraction where in the denominator we're taking the third root of something that's a perfect cube. So question, are there any multiples of 32 that are perfect cubes? Totally, 64. So is there anything we can multiply this fraction by, of course the same thing in the numerator and denominator, so that we end up with the third root of 64 in the denominator? Absolutely, the third root of 2 over the third root of 2. And look how nice that outcome is. We end up with just the third root of 2. Now can you imagine trying to rationalize this denominator by multiplying this fraction by the third root of 32 over the third root of 32 2 times? Then we'd end up with 4 times the third root of 1024 over the third root of 32,768? Well, at least we know the denominator would be 32. But the third root of 1024, I have no idea how to simplify that. It'd take me forever. And look how much more efficient this top way would have been. There is one more way we could have handled this original problem. Note that in a denominator, we're taking the third root of a pretty big number. And so that's why it was kind of daunting. But note, we could actually have simplified the third root of 32 to begin with. And so our original fraction, of which we're trying to rationalize that denominator, we can simplify into this much nicer fraction, whose denominator I'm sure it'd be no problem to simplify. All we need to do is multiply by the cube root of 2 over the cube root of 2. So just another option for how to rationalize these difficult denominators. Alright, just one practice problem here. Why don't you pause the video, rationalize the denominator for this fraction, and when you're done, play the video, and we'll see how it went. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.